Hey, welcome. A lot of us think about climate change as this slow, steady, predictable slope. But what if that's not the whole story? What if it's actually more like a series of sudden, terrifying cliffs? Today, we're going to dive into the science of what are called climate tipping points. These are thresholds where even a tiny little change can set off abrupt and sometimes totally irreversible consequences for our planet. So that's really the big question, isn't it? Is this a slow ramp we're walking up? Or are we getting closer and closer to a sudden cliff? It's at the very heart of what we're talking about today. Because the science is pretty clear that parts of our Earth system, well, they don't just bend, they can break. All right, so let's get into our first big idea here, these points of no return. Just think about that phrase for a second. These are critical thresholds where a system doesn't just change a little bit, it completely transforms, sometimes for good. It's kind of like that line you can push something across, but you can never, ever pull it back. Now, the official term scientists use for this is a tipping point. And you can see the formal definition from the IPCC right here. It talks about a system reorganizing abruptly and irreversibly. But what does that actually mean in plain English? It means we're not just talking about the planet getting a little bit warmer. No, we're talking about the fundamental rules of how something works, like an ocean or a massive ice sheet, just suddenly changing. Okay, to make this super simple, picture a glass of water sitting right on the edge of a table. You can nudge it, just a little and a little more, and it stays put, right? It seems totally stable. But then, one final nudge, and it might not even be any bigger than the others, and whoosh, it's not on the table anymore. It's shattered on the floor. You can't just nudge it back. That is a tipping point. So you might be wondering, what actually causes a whole system to just tip over like that? Well, the culprit is often this little thing called a feedback loop. And these are really powerful, self-reinforcing cycles that can take one small change and just amplify it until it's completely out of control. The basic idea of a feedback loop is that the result of something happening becomes the cause of it happening again, even more. The classic example is microphone feedback, A tiny sound from a speaker gets picked up by the microphone, which then blasts it out of the speaker even louder, and it just creates this deafening runaway squeal. The main thing to get here is that these loops can make a system really unstable. And in our climate, they can take just a little bit of warming and turn it into a lot of warming, all on their own. Okay, let's see how this plays out in the real world. For our first case study, we're going to look at the silent collapse that's happening right now in our oceans. We're talking about warm water coral reefs. You've probably heard them called the rainforests of the sea. So why should we care so much about these reefs? Well, this number, it kind of says it all. They provide services worth nearly $9.8 trillion every single year. And that's not just about tourism or fishing, it's also the very real physical protection they give to coastlines during huge storms. And, it's not just about the money, it's about people. At least 500 million people depend directly on these reefs for their food, for their jobs, for their safety. So when these reefs collapse, it's not just an environmental problem, it's a massive humanitarian crisis. So for years, scientists have been asking, where is the edge of the table for coral reefs? They've been trying to find that exact temperature threshold, that point of no return. And the research has zeroed in on a specific, terrifying number for global warming that basically spells disaster for these vital ecosystems. And there it is, 1.2 degrees Celsius of warming above pre-industrial levels. This is the scientifically identified tipping point for warm water corals. And here's the part that should really get your attention. Global temperatures have already warmed by about that much. I mean, this is not some far-off future threat. We are right at the threshold for widespread, irreversible collapse, right now. Beyond this point, the system doesn't just get sick, it fundamentally flips into a barren, algae-covered wasteland. Okay, now let's pivot. We're going to go from the warm tropics all the way to the frozen Arctic to look at a tipping point that's basically like a ticking carbon bomb. We're talking about permafrost, those huge stretches of permanently frozen ground that cover so much of the northern hemisphere. Wow. Okay, just take a look at this comparison. It really puts the scale of this problem into perspective. Our entire atmosphere, everything above us, holds about 830 petagrams of carbon. But locked away in that frozen Arctic permafrost is more than double that amount, up to 1,700 petagrams of carbon. It's this enormous reserve of ancient carbon, frozen solid and stable, at least for now. So here's how that ticking bomb could actually go off. It's a classic feedback loop. Step 1, the planet warms up a little, and it starts to thaw the permafrost. Step 2, all these ancient microbes that were frozen suddenly wake up and start eating all that organic matter, and as they do, they release greenhouse gases. And here's the really crucial part, steps 3 and 4. Those gases cause even more warming, which then brings us right back to step 1, thawing even more permafrost. The system starts to feed itself. It's that microphone squeal, getting louder and louder, and nobody is touching the dial. So, we've got a tipping point in the tropics, and we've got this dangerous feedback loop up in the Arctic. But here's the thing. These are not happening in separate little bubbles. They are deeply, deeply interconnected, and this is where the global picture starts to get really alarming. And this right here is the critical connection. That carbon bomb in the Arctic, it doesn't just have a local blast radius. As that permafrost feedback loop starts to spin faster and faster, it pumps tons of greenhouse gases into the whole atmosphere, which accelerates warming everywhere. And all that extra global heat makes it pretty much impossible for coral reefs to survive, pushing them way past their 1.2-degree tipping point. The collapse of one system can literally cause the collapse of another one halfway across the world. But here's the thing. This research doesn't just give us warnings. It shows us two completely different futures. Just look at the two paths here. The high emissions path, that top one, it leads to 100% of this permafrost thawing, and that would add over a full degree of extra warming from this feedback loop alone. But look at the bottom path, strong mitigation. That path keeps the thaw to a minimum, and it adds almost no extra warming. It is a dramatic fork in the road, and the choices we make right now are what decide which path humanity ends up on. And that brings us to the last, and frankly, the most important part of this whole story. This data doesn't just show us a problem. It shows us that we have a choice. The worst-case scenarios are not yet set in stone. This brings us to a really crucial quote from one of the core scientific papers we've looked at. Despite all the dangers, the scientists conclude that with strong action, it is, and I'm quoting here, still possible to prevent the release of large fractions of this permafrost carbon. The message from the science could not be clearer. The cliffs are real, but we haven't actually fallen off them yet. The actions we take today will decide which path we follow. So, in the end, we're left with this choice. The science has given us a map. It shows us where the gradual ramps are, and it clearly marks where the cliffs are. The real question isn't just about what the future holds for us, but what future we are going to choose for ourselves. A slow climb or a sudden fall.